just to summarise the different statistics that can be used for the platelets measurement. And I've got the cases in here too, so you can use means, standard deviations, give the variation of individuals about the mean, standard errors measure the accuracy of the mean. And then we've got medians, and while the median for the normals was quite close to the mean, for the cases something odd's going on. We've got a median of 0, so more than 50% of the cases have got 0 value for platelets. And we can see that here on the box and whisker plot. That's the median value. This box and whisker plot also shows the interquartile range, so 50% of the middle values of the data for the cases are from 0 to 50, and then for the normals it's 477 to 725, so that's the values we found, and we've got the minimum and the maximum. But hopefully you can see from this that summarising the cases just by means and standard errors isn't perhaps the right, or the most informative way to do it, because we've got a mean of 37 and yet our median is 0, and you might want to therefore use the median and the interquartile range and possibly the overall range as well, because I think this box and whisker plot, which kind of plots those values, gives a much better feel for what's going on with the cases. Of course you don't know exactly how many have a value of 0, but you do know, in fact, there's at least 50% of them, but not more than 75%, because the upper interquartile range was a value of 50, so 25% of the values are above 50. But for the normal data, this box and whisker plot shows that probably the mean was a reasonable way to summarise the data. Of course, if you're comparing the cases and normals, you can't really sort of have in your report put a median for one and a mean for the other, so you'd have to think carefully about how to present the data. You've got to decide whether to use medians or means. If you can use means, I would use them. So if the data are reasonably symmetrical, use a mean, or if you've got a large data set, but if the distribution does look quite odd, and what you could do is get the median and the mean and see if they differ a lot. But if it looks quite odd, it might be that the mean isn't the best summary statistic. Another thing to think about, which we'll be talking about when I come on to statistical analysis, is that sometimes a transformation of the data can make it more normal. A common one to use is to take logs. If you've got something where you're counting things, for example, numbers of cells, by taking logs, it can lead the distribution to be more normally distributed. And of course, there's other transformations you could do, like taking the square root of the data, or I don't know, more sophisticated ones that might make the distribution look a bit more symmetrical.